No.
Okay.
Okay, go for it. Where are we at?
Okay. I want to start with the question number 537, page 388.
Okay. Number 5. Okay. All right.
Okay. And the scale is wrong with me. I'm not sure.
Yeah, you can't. So you can't say this is 0 and then go to 170, for example, because then you're saying that your scale is 170. So the next one would have to be 340. So you're going to have to make your scale. I would highly recommend this scale shouldn't be by 1. It should maybe be by 12. So it ends up being years, 12 months for every step. Do you guys see what I'm saying? That's not a bad idea. Or you could use 10 or something. You don't want this scale to be necessarily 1. And then this scale needs to be able to go up to around 170, 180, 190. So you're going to have to go by maybe 40 or 30 or something.
Okay.
Coming in. Hello. Does that make more sense for that?
Yeah.
Okay.
Yes. Okay. And question number 6. Explain what is mean.
Oh, sorry.
Yeah. Yes, I just have a slope, but you say a question mark about explaining what it means. How I can explain the slope? By word is not, or I supposed to draw a picture?
No picture. You already got a picture. Your picture is going to be this.
Okay.
So guys, everybody, the first step to figuring out what slope is, what goes on the top to figure out slope? What do you put on the top to in the equation to figure out slope? Which letter?
The X.
No.
Why?
No?
Y's. Y's on the top.
Uh-huh.
And the neat thing is, isn't slope rise over run?
Yes.
Doesn't rise rhyme with Y's?
Yes.
There you go. So it's rise, Y's. Run is the other guys. So now listen. So Y's on the top, X is on the bottom. What units is on the Y-axis? That's going to be the top.
Okay.
Look at your number 5. What units is on the Y-axis? What units is on the
Bound.
pounds? And what units is on the X-axis?
Month.
Months. So it'll be pounds per
month.
There you go. And now kind of flesh that out just a little bit, but that's a great starting point. Oh, it's the pounds he gains per month, blah, blah, blah. I won't say anything else. Does that help?
Yes, a lot.
Always start with the units and then just kind of, say it like a normal person, but the units will tell you what the slope means. It's great.
Okay. And the question number 12, please.
Which one, sorry?
12.
12. Good old Bubba. Oh, what weight did he start at?
30 pounds.
No, listen, I love you guys. I love you guys so much. How many people do you think start college weighing 30 pounds?
Oh, no. Oh, this is my mistake.
Yeah, he started at 170 pounds.
Okay, this is my mistake. Okay, I find it.
There's a couple of people that did that, and I was like, that's not impossible, I guess, to have a very small
maybe
person.
Kilogram is okay, but pound, no.
Yeah, 30 pounds is kind of pushing it.
Okay. Yeah. This perfect.
How's everybody else?
Yeah, I have a lot.
I have a question.
Oh, Ethan, what's up?
I'm trying to find the one I had trouble on. I think it was number 8 on 3-8. Yeah, it was.
3-8. Oh, let's see. All right. The minimum safe tread thickness, convert this thickness to millimeters. Are you having trouble on that step?
No, I already I did the conversion correct. I just
Then
Everything
decide
else
how many more miles the owner of these tires can drive before he risks life and limb driving on. Oh, okay. The minimum safe tread thickness is 1/16 of an inch, which you converted to millimeters. So now you know how far the tread's got to go down until it becomes dangerous, right? And if I remember correctly, you should have a formula somewhere here. Yeah, you have a formula you developed earlier that tells you how much tread is left after so many miles, right?
Can I say it to clarify?
Yeah, good.
Is it y equals mx plus b? Is that the one?
No,
Or is it
because
the
that's every line that ever existed and ever will exist. I want this line. What's the equation you got for this line? You must have gotten it on number
Was it
5,
the-
right?
Was it the y minus y one? That one?
No, listen.
Oh
Uh,
yeah. I'm
The equation is going to be something like y equals 4x plus 7, or y equals negative 20x minus 2, or that's the equation of a line for a specific situation. I don't want to know the equation of a line in general. I want the equation of this line, which is what you got in number 5.
Oh, okay. Y equals, was it negative 0.12 x plus 9?
Beautiful. And now, what does y mean? What does x mean?
Y is the tread thickness and x is the miles.
Yes. So on number 8, you know what you want the tread thickness to be, right?
Right.
So can't you plug that in and figure out, solve for the number of miles, solve for x?
Yeah, I mean,
There, done. Yeah.
you're right. I don't know if I got it wrong, but that's the thing. It was just I had a hard time on it yesterday.
Did you do that? Is that what you did?
Yeah, I believe so.
What'd you get?
Was it he can drive about 26,000 more miles?
Nope.
Yeah, see, I got lost somewhere.
What'd you get when you converted 1/16 of an inch to millimeters?
Is it 1.59?
Yes, good. So now you plug that in to the equation you told me from 5, but what letter do you plug it in for?
X, correct?
Definitely not. You told me correctly earlier.
Oh, my bad. I'm not looking at the chart.
Y is the amount of tread,
Tread-
X is the number of
tread
miles.
Oh, Y.
You got to plug it in for Y. So you got to solve for X.
Okay.
Yeah.
Okay. I think that makes things a lot more clear. Thank you.
Yeah. So that's why it's really important to remember what the variables mean. So you plug numbers in the right place. Yeah.
Awesome. Thank you.
Sure. How's everybody else? Oh,
I just struggle on number 7 on the same homework.
number 7. So again, did you get the same equation for number 5 that Ethan was telling me he got? Hello?
No, I didn't. Like I think I did something kind of different.
Yeah, so number 7 is never going to work if you don't have the right equation, because number 7 is all about sticking 50,000 or 50 in, because it's per thousand, into the equation. And if you got the wrong equation, it's never going to work. So here you've got to figure out, let me catch up. Number 2, you figured out the slope. Right?
I didn't figure out the slope until number 5.
No, right here.
That's what happened. Yeah.
Find the rate at which the thickness is changing compared to 1,000 miles. That's slope. Slope is a rate of change.
Right.
So now you know what m is, right? And number 4, you were supposed to write the point slope form. And number 5 would just be solve that for y. So what'd you get for number 4?
4. I kind of did it different. Number 4, I wrote 7.2 equals m times 15 plus b.
1.2.
7.2.
Specifically says you have to use this. And don't worry, don't feel like you're out there on your own. Trust me, there are other people having the same issue you are, okay? So I'm not trying to make you
I
an
was
example or
really
something.
lost. I was like, what in the world? Like,
Hold on, guys. My new setup here, I forgot. So 2 things. Let me make it all about me, and let me change my monitor so I can write. Here we go. Oh, okay, here we go. Okay.
me too.
Sorry.
That's honestly me today too.
So for number 4, oh, scheisse. I gotta tell this thing to be right. Hold on. There's so many freaking buttons. Y minus y1 equals m times x minus x1. That's the equation you need to use. So you know what m is from number 2, I believe. And you just have to pick a point that this goes through, plug it in. And you know 2 points that this thing goes through. Is that making sense, Paul?
Yeah.
Here you got 2 points this thing goes through right here. So you can pick either one of them and plug, like if you pick the first one, you put the 15 here into the x piece, and you put the 7.2 here into the y piece. And then you put your answer to number 2 in for m.
Oh, okay.
So for number 5, it's just going to be take that equation and solve it for m.
Oh, okay.
I'm sorry. What did I say? Solve it for y. Because that'll put it into
Because we would know the
y
slope,
equals mx
right?
plus b. Huh?
Yeah. Because we would know the slope.
Yeah, so you know the slope from number 2, so you can plug that in right here. Oh, goodness gracious. I love it. There. Are you going to be there forever now? Yes, okay. Yeah, so this is number 2. Number 2, you figure out the slope. You put it there. And number 1, they gave you 2 points. So you just pick a point and put the XY pieces there. And then number 5, you solve for y. And it puts it in that form, right?
Makes sense.
Okay. Everybody else, is that all right? Do you have any other questions? Everybody good? All right.
They got another struggle somewhere too. I gotta figure.
Okay.
Number 9.
Oh, well, I mean, again, yeah, you're going to have to, you got to get the equation put together before you can do everything. The answer to number 8 is going to be the number of miles before it's unsafe, right?
Mm-hmm.
And then number 9 says, well, let's see. Wait, what is that? Oh, so this, what would this mean, everybody? The particular model tire has tread thickness of 9.2 when it is brand new. So it's after 0 months. So what does this information actually tell you about the graph? You can do it.
The y-intercept.
Y-intercept, I love it. I love it, the y-intercept. In number 5, you actually figure out the y-intercept. When you solve that equation, you're going to see what b is. Does that make sense so far?
Yeah.
So this is saying it's supposed to have 9.2 at the beginning, which means b should be 9.2. So once you figure out what b is, you can see how close it is to this, or if it's different from that. Oh man. Sorry, I'm a little bit congested. that better? Is that all right? Does that make any sense? So in number 5, you're going to figure out what the equation is for the line. You're going to figure out mx plus b, and b is the number that's in the y-intercept. And if it isn't 9.2, like it's supposed to be, then you can say, no, it doesn't match. Yeah, you got it, Ethan. All right. Is that better, or is that
Yeah, that's better.
all right?
Thank
And
you.
the answer to that question can be no. It's fine. I always worried that somebody's like, I don't understand what the hell this man just said, but I'm not going to tell him that. Of course, you can tell me that. All right. All right, guys. Anything else before we get back into where we left off? Okay, all right, so let's do that. Let's see. I think, if I remember correctly, oh my God, where is it? Here we go. Oh yeah. Interesting. All right. Yeah, we basically finished 4-1. I mean, we've talked quite a bit about 4-1. Just to kind of show you the homework, right? We did triangular numbers. Here's square numbers, right? Look at this, pentagonal numbers. Excuse me? Pentagonal numbers. Yeah. So you got to figure out what the relationship is here. That should be neat. Now look at this. This is neat. Anyway, some nice, beautiful algebra kind of looking stuff. I love it. Oh, buddy. All right, sorry. Then you've got some counterexample stuff. You've got some inductive versus deductive reasoning kind of questions here. And then that's it. So it's not really a ton of stuff there for 4-1. Let's do this real quick. Let's just do a couple of these. What does a square root mean? What's the square root asking you? Oh, I'm sorry. Well, shit. That whole thing was fantastic, wasn't it? Oh, Jeff, you're so funny. I'm teaching myself. All right, what did I just talk about? Oh, here. Shit. I'm sorry, everybody. It's fine to break in and say, hey, crazy dude, you're not sharing your screen. Okay.
Yeah, sorry. I thought you were just explaining something for a while. and I-
It's all right. It's my fault. It's my fault. It's not your job to keep me straight. Okay. So I just wanted to look at the homework here real quick. There's square numbers, pentagonal numbers, nifty. It's just fun to say the word pentagonal. Some algebraic stuff related to these. These are actual formulas to figure out whichever square number, pentagonal number, triangular number that you want. Okay. Then they've got some counterexample stuff and some inductive, deductive reasoning stuff. Okay, so not a ton of stuff in there. So just to really make it as clear as I can, inductive reasoning is when you have a few examples and then you try to make a general conclusion, like figuring out the next number in a sequence. You got a few examples, you're trying to figure out the general pattern. You with me so far? That's inductive reasoning. Inductive reasoning is useful in that very often it's the only kind of reasoning we can use, but it could lead to incorrect conclusions. Deductive reasoning is when you start with a variable, and that's the one that actually proves something, and it's always going to be a little bit more complicated because it's trying to prove something. All right. So let's get back up to here. What is the square root ask you? If I say, what's the square root of 49? Does anyone know the answer to that?
7.
Why?
Because 7 times 7 is 49.
Good. So what's the square root asking you to find? Can somebody?
Put it into words.
Something times itself.
Yeah.
Good. I like to say this. The square root, the question that this symbol represents is, what does it take 2 of to multiply to be this thing, whatever is inside? What does it take 2 of to multiply to be this thing inside? So if I put in here 25, what does it take 2 of to multiply to be 25?
5.
Takes 2 5s. I like it. So this is the thing. Has anybody ever taken a foreign language before?
I am taking one right now. I'm taking Russian.
Russian. All right. Good. Privyat. Anybody else take any other foreign language? Anybody? English could even be your foreign language, correct?
Yes.
Right.
Technically Spanish.
Technically Spanish. Interesting question.
Yeah.
Interesting answer. I'm not sure what that means. Anybody else? So we got Spanish, we got Russian.
My
Anybody else
mom's
taking
teaching
any?
me.
Say again?
My mom's teaching me.
Oh, okay, cool. No worries. That's even better. It's free, right? All right. Either you don't want to play along with me or you haven't taken any foreign language. When you take a foreign language, part of it is you've got letters that are symbols. When put together, you have to figure out what it means in your original language, correct? So that's what math is. This is a symbol that represents a complete sentence question, right? I don't know if you guys are still with me or not. I'm making a big deal out of this, I know. But so much of mathematics is getting over the symbols that were chosen and focusing on what it means, right? So what's wrong with this question? Is there an answer to that question?
It can't be the negative
Why not?
because if we use the root 2, it's gonna be -2, and -2 by -2 is gonna be +4.
Yep.
Exactly. So there's no real number answer. All right. Just to freak you guys out, there is an answer to this. There is. But there's no real answer to it. The word real doesn't mean that other numbers are fake. It's just a word that we chose back in history. It's an unfortunate word. Anyway, I'm not going to go into complex numbers and imaginary numbers. I don't know if anybody's ever heard of those. But for us, if we saw a square root of a negative number, we would just say, no real number, no real answer. And that would be it. You guys, does everybody understand why there's no answer to that?
Yes.
There's no real number I can multiply by itself and get -4. Because if it's negative, the negatives cancel. If it's positive, how could it become negative? Oh, shit. Okay. What's the square root of 0?
0.
Yeah, buddy. What's the square root of 4 knights? What's the square root of 4?
2/3.
Yeah, 2/3. Look at that. It works exactly how you would hope it would work, right? Maybe? Is everybody okay? Okay. All right. So I'm not going to do this for you. Let's see. Let me clear this away. Wow. Now, the reason that we're talking about square roots is because we're about to get into this thing. Has anyone ever heard of this thing before?
Yep, a long
Yes.
time ago.
Long time ago in a galaxy far, far away. Okay. I like it. Now, so what the hell is that Pythagorean theorem? What is it? What is it? So we're going to work our way there. Real quick, this is a little bit of a side note in a way, but have you guys seen things like this? Seen signs like this before? Anybody?
Yeah.
Yes.
Right? Have you guys ever seen a runaway truck ramp on the side of a road?
Yes. The gravel things.
Yes. So if you don't know about this, when you're on extremely steep roads, next to the road there will be a runaway truck ramp because sometimes trucks' brakes give out and they need help to stop. So that's why there's gravel, because it's going to make the truck stop. And I remember the first time I saw one of these, I was going across country for the first time ever. And I was in Colorado and I saw one of these signs and I was like, holy shit. I was looking behind me all the time. Anyway, in San Diego, there are several roads that are very steep. I used to live in Mission Hills. There's very steep roads there. There's the one that goes towards the airport, I think. I can't remember what street that is, but it's like they have a stop sign and then you go, wah! I don't know if anybody knows what I'm talking about.
I know exactly what you're talking about. I know
What the
exactly
shit?
where.
What does this mean? 8% grade.
Is it the angle?
Okay, it's related to the angle. Now, we're not going to get into trigonometry all of a sudden, but does somebody know what it means relative to what we've discussed very recently?
Is it the slope?
Slope. I love it. What is 8% as a fraction?
8 over 100.
8 over 100. So this would be, I would rise or fall. So if I did 8% grade, but I was going down, so it's really -8, I would fall 8 feet for every 100 feet I go forward. That doesn't seem like a lot, but when you're going 50, 60 mile an hour, that's quite a bit of fall. So that's decently steep. I don't know. Are you guys, did anyone ever know that before? How to interpret the 8% or 9% or whatever percent grade?
I had a feeling that's what
No, I had no idea.
Does it make sense now?
Yeah.
Yeah.
8%. So it's kind of beautiful. Slope is a ratio. Ratios can be turned into percentages. So that's how they identify slope on the road, is through percentages. Perfect. All right. Thank you. Let me see. Let me clear this away. Bam. The main thing in here is this is a triangle here, right? Triangle. So it's going to come into play. Obviously, Pythagorean theorem relates to certain kinds of triangles. Oh, they got a nice picture for me here. I like it. Now let's see let's see. All right. Here we go. What's the change in elevation over a 1 mile stretch of road with an 8% grade? So I'm trying to figure out what this is right here. Oh, shit. This is kind of beautiful that we changed this into a percentage. So again, 8% is 8 over 100, Jeff. So for every 100 feet forward, I would go 8 feet up if I'm going up this road, right? I have no idea. This is my pathetic try for a truck. It's horrible. Let me blow it up. Okay. You guys with me at the moment? I really want this to make sense. This is kind of beautiful that we make this a percentage. 8%. So this means that 8% of the forward motion is up. How much am I going to go up? 8% of the forward motion. 8% of 5280.
So you multiply that by 0.08.
Yes.
And then add that product.
No.
5280. Oh wait, is it minus the product?
No, you don't do any of that shit.
Multiply.
All you do is this.
Okay.
I really want this to make sense. So if I go forward 100 feet, what does my slope say? If I go forward 100 feet, how much do I go up? What does my slope say? If I go forward 100 feet, I go up how much?
8.
8 feet. What is 8% of 100?
8.
8. So whatever the forward motion is, I'm going to multiply that by 8% to figure out how much I actually go up at the same time. So can somebody do that for me? What is that?
422.4.
0.4 feet. Oh, crap. Well, we can do this. There we go. 422.4 feet. Holy macaronis. All right. So that's actually a nifty little side note because it's kind of like extending our idea of slope to be able to used in to be able to be used in more creative ways. All right. So let me.
Excuse me, Professor.
Yes.
Can you say again what was the unit of 422 feet on what?
I'm sorry. Let me
Yeah.
erase this. My writing got exceptionally bad there at the end. 422.4 feet. Done. Because this is 80% of 5,280 feet. So of course the units is still feet.
Okay, thank you.
So if I go forward 1 mile, I end up increasing my elevation by 422.4 feet. Is that all right? Does that make sense? Sort of like, has anybody ever gone hiking?
Yeah.
And have you gone hiking on like kind of steep trails?
Yeah. Yeah.
Does anyone ever have an elevation app? Do you guys know the elevation app on your phone or anything?
Mm-mm.
No, but you know about increase and decrease in elevation, right? So if I hike forward so much, I can figure out how much I increase my elevation, and then I can figure out the slope of the trail, right? So everybody,
Yeah, that's true.
that's true. Okay, thank you. Okay. Let me clear all this away. It's gonna go away. All right, go away. Blah 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 blah. Now let's get into. Oh no, they gave it to me. Sorry, I just like to talk about it before they just throw it at you. Does that should look familiar to a lot of us, right? Let me show you something. Tell me if you've ever seen this before. All right. So let me draw something off of B that's also B. You go away. What's the area of that square I just drew?
B
by
by B.
which is B squared. Now let me draw a square off of A. It's going to be bigger. What's the area of that square?
A squared.
A squared. And then, of course, I got this big ass thing off of C. What's the area of that square?
C squared.
So all the Pythagorean theorem says is the square on the side of A plus the square on the side of B equals the square on the side of C. And there's a really cool, I wish I would have looked it up before class. I always forget to do this. I got to find this video. There's a really cool video. Somebody created a physical interpretation of this, and he has this full of water. And when he turns it, the water goes into this one and this one perfectly. It fills it up perfectly. Does that make any sense to anybody? So he puts water in here and fills it up. And then when he turns it, it goes into here and it goes into there and it fills it up perfectly, proving that this area is equal to the sum of these two areas. Does everybody hate what I just said? Is that what's happening?
No, you're fine.
Okay, all right. We're indifferent. All right. So let me ask you
that C is bigger than A and B?
Yes, good. This is a very good thing to point out. The side C must be the side that is across from the right angle. No, you hate it. Oh, I see. No hate. I thought you were saying no. I hate it. All right. All right. So let me know if you find it, Guillermo. What was I about to say? So again, here's the equation. The sum of the smaller side squared must be the largest side squared. Why is this always going to be the largest side if it's across from this? How big is this angle here? What's this
No.
angle?
90
90,
degrees.
90 degrees.
Here, let me clear all my crap out of here. All right. So this is 90 degrees. So are either one of these two going to be 90?
No.
45.
They don't, do they have to be 45?
They
No.
can be anything.
They can't be anything.
Well, they can be
The
anything.
total 90. The total.
Yes, because how many total degrees are in any triangle?
180.
180.
I love it. So my point is, these two will always be smaller than this one, correct?
No, same.
Excuse me?
Both is same.
No, these two individually will
Yeah.
always be smaller than this one.
Yes.
Oh, okay. Yeah.
Neither one of these will ever be as big or bigger than this one. Okay, good.
Mhm.
I like to think of an angle as something opening its mouth. Sort of like the Rancor in Return of the Jedi, open his mouth and Luke stuck the stick in there and blah, blah, blah. No, okay, sorry, too much Star Wars. So this thing opens its mouth the most. So of course the side across from it's going to be the biggest. Okay. Is that cool?
Yeah.
All right, does that make sense? Okay, I don't know if you've ever looked at it that way or how much geometry you've ever done or any of this stuff. So if we do a specific example, let's do a specific example. Let's say this is 5 and this is, well, say, yeah, all right, Jeff, let's do this. Let's start not too crazy. Let's say this one is 3 and this one's 4. Can somebody figure out what that is? Which letter is this unknown?
7.
Definitely not. Definitely not.
No.
All right, I really want you to understand there's a few different levels. If I put a piece that's 3 next to a piece that's 4, then that's 7 total in length, correct?
It's 5.
Yes, it will be. But yeah. So if I pick this piece up and put it like that, there's no way that these are 7 apart because they've gotten closer, haven't they?
Yeah.
Yes.
Okay. So hypotenuse will always be smaller than the sum of the other two sides.
Yeah.
It's the fact that they're squared that makes this thing work. What am I going to call, what letter do I give this unknown side? It's got to be a certain letter.
C.
C, because it's across from the right angle. I love it. So how do I set up the equation?
So 3 squared plus 4 squared equals C squared.
All right, now if you haven't done it yet, take a quick second. See if you can solve that. Don't say anything. I think you already said the answer, but just make sure you can solve it. Everybody. Can you solve that? Oh my goodness, gravy. Keep blocking the Death Star. Is that sacrilegious? Blocking the Death Star. All right, let me catch up to you guys. So that's 9 plus 16, 25. So of course we did this one earlier. What's C gotta be? I think you already said it.
5.
5. Has anyone before today heard of a 3, 4, 5 triangle?
Yeah. They're like a common triangle or ratio.
It's a possible triangle, right triangle, right? Most right triangles are going to have gross side lengths because, all right, so for example, let's try another one. Let's try this triangle. What about a triangle 2, 5? Can you figure out that?
No, because this is not a square number.
No, you still can figure it out. It's just not going to be pretty, right? So
Yeah, it's
we
gonna
don't throw out
suggest-
numbers just because they're not pretty. So let's try it out. You ready? So it'll be 2 squared plus 5 squared equals c squared, correct? So 4 plus 25, 29. So does anyone know what c is? Don't worry, you can't give me the answer. How would I write the answer? Why was the answer here 5? What did you do to 25 to get 5?
5.5.
Stop. I don't care about that.
Oh,
I want the exact answer. What did you do to 25 to get 5? You can tell me. What did you do? Anybody? What did we do to
On
20?
the square root.
Took the square root. So what do we do here? How do we get C? What do we do to 29?
Square root of 29.
Square root of 29. Now you can plug that in the calculator and you can give me a number, a decimal, which will always be wrong. It'll always and forever be wrong because can anybody tell me if I wrote the decimal for this and I want to write the complete decimal, how long would it take me to write it? Does anyone know? Who was telling me? Alariza, was that you that put it in the calculator?
no, I didn't put in the.
I'm sorry,
calculator.
somebody, I forgot already who it was.
I said 5.5.
Is that what you got from the calculator?
No,
Oh, you were just guessing.
yeah.
Oh, okay. Does anyone know how to plug this in their calculator?
Yes, I think so.
What do you get?
So
See, and that was
5.38.
5 point, and doesn't it keep going?
Yeah, 385164807.
Now, why do you think it stops here?
Um,
Because it gives up. It
okay,
doesn't
I
have-
was like,
there's no more room for it to keep going, right? That actually goes forever. If there's a square root that doesn't become a whole number, then that means it's an infinite decimal. Is everybody with me out there? So that's why if I ask you to give me the answer as a decimal on a test or something, I got to tell you how to round it, how much to round this to. So what if you round this to the hundredths place? Hundredths. What would you get?
I'm not answering that. I'm yawning. 5.38.
No,
No? Oh, 5.385. My bad.
no,
No?
5.39.
Oh.
They had
I
the place
did
right
wrong.
because the next number was a 5.
Okay, my bad.
So everybody out there, you guys doing okay? Okay, I'll take that as a yes. Let me see. I'm going to clear all this stuff away. So using the Pythagorean theorem is not too freaky. Let me do one more example that gets a little bit. You got to be careful. Let me clear all
I
this
have a
over.
quick question.
Yeah.
So when we're writing down, let's say we have a question like that on our homework. When we're writing it down, would you prefer the c equals square root of 29 or actually get the square root of 29?
If they don't say,
Right.
leave it as this.
Okay.
They might say right answers as decimals rounded to the 10th place or something. Then you do that.
All right. Sounds good.
But if they don't say, we normally just stop here. Now, if it's like a problem and you're trying to figure out how many miles your house is away, right? How many miles are you away from the house? And you tell me you're square root of 29 miles away.
Yeah.
What the shit? Who the hell talks like that? Hey man, how far away are we? Square root of 11 miles. Who are you? It's like, just say a little over 3 miles. What the hell are you talking? Anyway. So yeah, if it's a word problem where you got units, we normally don't talk like that in real life. We don't say square. But if it's just a number problem and they don't say, leave it as a square root. Okay.
Sounds good. Thank you.
Clear this away. All right, let me do another problem. What about this one? There's a little something different about this problem. Crappity doodah. That's a 13 there. Why do I write so small? Can you guys see that? Do it again a little bigger. 513 right angle. There we go. Little tiny dude, go away. Can you figure out this side. Is the unknown side C?
No.
Which side is C?
13.
Good. So when you set this up, it's going to be a little bit different, right? It does it really matter if you call this side A or B?
No, doesn't matter.
Good. It doesn't matter because I could just turn these around and it would be the same thing, right? So I'm just going to call this A. So that means this is B. So what's the equation look like when you set it up?
A plus 5
No,
equals 13.
No.
Oh, x square, sorry.
Yes. A squared plus
Plus 5 square. Or
y
20.
squared equals
13 square.
squared. Good.
Yes.
Sorry. I just want to make it. It only works when they're squares. Yeah. So go ahead and try to solve that if you haven't tried already, if you set this up. Okay. So this is going to be a little different, right? Because you have to solve for A. Of course, what do I do here?
Subtract 25.
And this is something you should know. What's A if A squared is 144?
12.
12.
So now we have a 5, 12, 13 triangle. So there are certain triangles where the sides are whole numbers. But there are a lot more triangles where the sides are gross, like the square root of 29, right? How's everybody doing? You guys all right? Are you guys all right? Let me see if I can push this a little bit. What if I had a triangle that was 10, 24? Can somebody figure out what this is without doing barely any work? You shouldn't have to set up a Pythagorean theorem. See if anybody gets this.
18.
68.
Say it one more time, sorry.
18.
No.
Okay. Just a shot in the dark.
I understand. How is this triangle related to this triangle? That's 5, that's 10. That's 12, that's 24.
Oh, it's 26.
Double.
Yes. It's just
Okay, it's
twice
just
as
double.
big as this one.
That makes sense.
It's just further away. That's why it looks smaller. So it's not drawn to scale. But does that make sense, guys? I can just scale up a triangle. I can just double all the sides or cut all the sides in half or something like that, right? Does that make sense? No. You hate it? Okay. I'm going to clear all this away. Here it goes. Oh my goodness. So here they have a bunch of stuff. This one, now look. Square root 11, isn't that funny? That's the one I just said. What is that between? What do you wish? What's the next number down from 11 that you wish was inside there? Because then it would be easy.
10.
9.
9, correct? Now somebody else tells me what's the number up from 11 that it could be to make it easy.
Can I say?
Say again?
Can I say?
Go ahead.
16.
All right, let me stop for a minute. Does everybody see that? It's 11. That sucks. I wish it was 9 or 16. Aren't those the closest numbers on either side that would work beautifully, right? What is square root of 9?
3.
And what's the square root of 16?
4.
So then you can guess what the square root of 11 is. It's between 3 and 4, right? So you can just kind of guess. It seems to be a little closer to 9 than 16, so you might guess something like 3.2 or something. Does that make sense to anybody?
Yeah,
You
totally.
can estimate what the square root is. Now, can somebody do this if you found your square root button? What is the square root of 11? Let's see how close I got. Well, I didn't do too horrible.
3.31.
Yeah, 3.32 really, but that's
3.2. Oh, it's the same.
if I round to 100. Anyway, so that's how all these work. Can you guys figure out what the numbers would be here? What's 78 between? That would be beautiful for square rooting. You can do it.
64.
64. And what's up here?
81.
81. So that means that has to be between 8 and 9. All right. So that's a beautiful idea. I really hope you agree. I'm going to clear all this away. Ooch. Who cares? All right, let's see if they got anything good. Ooh. Oh, well, this is an interesting question. Oh, yeah, this is where we get some cool shit. Yay. All right, sorry. Let's talk about this real quick. If you went from A to B straight, okay, that's one thing. What if you had to do this, that you're hiking, so you got to go down and then up? Which one of these is a longer distance between A and B?
It's the middle one, the bottom
Yes,
one.
this is definitely the longer distance, right? Now this gets a little bit freakier. This one, what if I went up and then I just dropped? Ah! Can you tell the difference between these two? Which one would be sorry?
Go ahead.
Which one would be the longer distance traveled? Is it easy to tell the difference between these two?
I don't think so, but I think the middle one is definitely longer.
Yeah, I would agree with you. I think this one's longer just because it seems to get further away. Do you see that? It gets further away from straight.
Mm-hmm.
This one doesn't get as far away from straight. But it's hard to tell. Okay, now the real point of this is the idea of, like we said earlier, elevation. Does anyone ever use Google Maps?
All the time.
All the
Have you ever
time.
turned on, there's an option called terrain?
Oh, like with the contours and stuff?
Yes. So you can turn on satellite, so you can see the satellite imagery. So you can, and there's also another option called terrain. If you haven't tried that option before, next time you're in Google Maps, you should try it. It'll tell you elevation changes, and you'll get something like this. The shit does this mean? This means, this is so neat. This means that every point on this curve is, let's say, 10 feet above sea level, right? You guys with me? So if I just walked along this curve, I wouldn't go up or down at all. That would be a nice, easy hike because I'm not going up or down at all, just going straight. If I went this direction, if I went straight from the 10 to the 20 to the 30 to the 40, what do you think that means? If I start here and I just walk straight this way.
You'd go uphill.
Yeah, I go uphill pretty quickly, correct? I don't know, to be honest. This is 200 feet. I'm not going to sit here and figure this out. But I would go up 10, up 10, up another 10 over this range. So I'm basically climbing this little hill decently quickly. So those of you who have gone hiking, when you've got a bit of a hill or even a mountain, do you ever see a trail that kind of goes straight up? What do you more often
have
see?
switchbacks and stuff.
Switchbacks, exactly, switchbacks. Which means you kind of follow, you go this, and then you kind of slowly come up here, and then you switch back, and you slowly go up a little bit more, you switch back, and you slowly go. So it's trying to decrease the slope you're experiencing if you do these switchbacks. I like it. Let me see. Oh, let's see. How does the distance between points P and Q compare to the distance between points M and N? So what's P? How far above? Oh, look, they got a whole other look here. I don't even want to look at that. How far above sea level am I at P?
20 feet,
Okay. And how far up am I at Q?
40.
40 feet,
So that's a difference of 20, right? How about here? How far up am I at M?
50 feet,
And how about N?
10 feet,
Yeah, so it's a difference of 40. So how does the distance between points P and Q compare to the distance between points M and N? Do you see how they look the same here? But I'm definitely going further here, aren't I? I'm actually traveling further here than I am here. For sure. Are you guys doing okay out there? So this is really cool. This is from above. And this would be from the side. So from above, I'm like, well, that guy went in a straight line and that guy went in a straight line. They both went the same direction. But from the side, I'm like, holy shit, this person went a lot further. All right, maybe. All right, so these are kind of neat. These contour maps. Do they call them topological maps? No, they're just called contour maps. Okay, but they're topological maps is another name for these.
Topographic.
Topographical. Yeah. Did I say topological?
Yes.
Okay, sorry. That's related, but it's different. All right. Let me see. Blah 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 blah. Oh yeah. So they're basically 2 and 3 are basically doing what we just said. Let me see if they do anything else interesting. Oh, all right. Let's do this one last thing. What time is it? It feels like it's. Oh yeah. Sure. We'll do it a little easy. Can you guys see a triangle here? Like right here.
From M to N, if you. I mean,
Yeah,
you
we
can
got
kind of
it.
make a triangle, right? Yeah.
All right. Can we figure out what the slope is from N to M to N? Like, what is this distance here?
40.
Good. Everybody see that? 50 to 10. So we got that answer earlier, right? 40. And what is this distance here? How are you going to figure that out? Well, don't they have that up here? Doesn't it look to be
Yes.
about this? It looks to be about this, right? It looks like that's why they did this. So let's say that's 200 feet. So I could figure out the slope, the grade of this. Are you guys at all with me? So let's figure out that. Let's figure out the slope. All right, now somebody else help me out. What would the slope be for this? So what goes on the top in words, starting with the letter R?
Rise.
Rise. All right. So how much does this rise?
40 feet,
40 feet. And how much does it run?
200 feet.
200 feet. So isn't this 20 over 100, which is 20%? That's a 20% grade. That is pretty steep. Okay, maybe. Are you guys doing okay out there?
But it's not look like 40 and 200. Look like the same as see it in the picture, right?
Wait. Say again, sorry.
You say the 40 and 200, but if I look like the same, or maybe 40 is more than the 200.
All right, guy. All right. Now listen.
Yeah.
You're assuming this scale up and down is the same as this scale left and right, but didn't they tell me the left and right scale? Doesn't this look to be about 200?
Okay, this is the difference. Okay.
So this is related to like the y-axis can have a different scale.
Yes, one is
Otherwise, I
100,
agree with you.
one is tens. Yes.
This
Yes.
does look a little longer than that, just straight, but I know that this actually represents a more distance. Yeah.
Yes. Yes.
All right.
Thank
Now,
you.
the slightly more interesting question is roughly how far would the person walk here? This is the actual distance they travel, isn't it? Because they're not going to burrow into the mountain and then burrow straight up. That would be a very strange way to hike. They're going to walk along the freaking mountainside, aren't they? Can you figure out how long this is?
Yeah, it's just 40 squared times or plus 200 squared.
There you go.
Stuff.
Equals, and we'll call this C, remarkably enough. We can even call it D. Let's just do that right now. We'll call it D for distance. Isn't that crazy? Just to get you all ready for the next thing. Try to figure out what this is. Ooh, yeah. Ooh, yeah, it's yummy. Round it to the nearest, what is this in? Is this feet? Yeah, round it to the nearest feet. Foot.
It's gonna be 5,600.
5,600. I'm not sure.
I got 40.
Oh, when you squared 200, you didn't have enough zeros.
Oh yeah, sorry.
Yeah, 2, and then another 2 because it's squared, and then 2 squared is 4. Of course, you can just do it all in the calculator too. But I'm sorry, did somebody else get the answer?
It's going to be around 204.
204.
Yeah, 204.
Oh,
Now,
you had to put the square. Okay. My fault.
I like it because it'll be, so it really is the square root. So D squared equals 40, yeah, 41,600. So then I have to take the square root. If I throw that in the calculator, I get 203.96, blah, 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 blah. Okay. All right. Here's the last thing we're going to do, and you're going to do it. Do everything we just did, but for this one. Do everything we just did. Don't worry about the slope. Let's just work on this. Slope is old news. Get the distance traveled, roughly. This isn't exactly the distance, correct? Because it's a little wavy, but you know, it's an estimate. Shit and a half. Stop it. That's not. That's kind of funny. I don't know why I thought it would be. How different is this? Yeah, I like this. Does anyone have that answer yet?
Is it like 201? Yeah.
Yeah, 201. So it's only different by 3 feet. It's kind of neat. Anyway, so you'd have to go a lot further to see the difference. This is not really that far, so it kind of makes sense. All right. So already got that. I'm going to stop sharing. You should have waited for an answer, Jeff. I know. And I'm going to say that is enough for today. It's kind of nice. We're going slowly. I'm trying to make room for questions and everything. That's enough for today. So let me know if you need to hang out. Otherwise, you are free to go. May the 4th be with you.
Professor, I have a question for after class.
Yeah.
I just kind of need help plugging in or how to use the square root function on my calculator.
Oh. What kind of calculator do you have?
I have this one. It's kind of janky.
Oh, that's perfect. All right. Can you hold it? I think hold it closer. Do you see an x squared button? There it is.
Right here.
Yeah. Now what's right above it?
Oh, okay. It's
So you
like
hit that second button, and then you hit the x squared. That second button's like a shift.
oh, okay, cool.
There you go, buddy. Yeah.
Awesome. All right, cool. Yeah, thank you. That's all.
I have that same calculator somewhere.
Yeah, this baby ran me through all of high school. Never used it, but I had it.
Just in case.
Yeah.
All right, man.
All right. Thank you, Professor. Thank you.
Sure. Everybody else okay?
I have a question. If you got my 3.7, because you told me to retake the picture.
Oh, thank
I'm
you.
not sure if
Yeah.
it's-
I get there was just parts of it I couldn't even tell. Let me see.
Yeah, I'm sorry. I don't know why it does that.
Let me make sure it looks okay now.
I took another one that's pretty darker that I could resubmit if that one isn't clear.
Let me see. So you're saying you resubmitted something, right? Let me see if this
Yeah.
one was. Yeah, it's still a little. That's better, but no, there's a lot of it I can't really see.
Okay, let me resubmit another one.
Yeah.
Or maybe I can take a picture like 2 times, like cutting it in half so it could be closer.
Oh, maybe. Yeah,
Would that be too much
try something.
files?
I've had the same issue with some of your stuff, but it's always I could always kind of make it out. But
Oh,
this
okay.
first one I couldn't really see like chunks of it. I can't see at all.
Okay, I'll take a picture like 3 times so it could be closer.
Okay. We'll try that.
Thank you.
Thank you. See you.